for us. So today's lesson is all about some applications for these determinants that we've been studying. So far we know how to find a determinant for a 2x2. We can find a determinant for a 3x3. But it'd be nice to maybe do a little bit of something with them. So today I'm going to show you a couple of applications for them. By all means, this is not all of them, but this is a few of them that we're going to study. So, ladies and gentlemen, we have a triangle here. Is that true? Yeah. And we've all been to geometry before because this is the Advanced Algebra 2 class. So, how do you find the area of a triangle? What would it be?
1/2 base times
1/2 the base times the height. Good. Could you please then find the area of that triangle for me right now? So, our area then is going to be 1/2. The base is how many kerplunkerbunkles?
6.
There's 6 kerplunkerbunkles, right? So 1, 2, 3, 4, 5, 6.
Is that a metric or
1, 2, 3, 4, 5. How tall is this thing?
5 kerplunkerbunkles.
5 kerplunkerbunkles.
God, I hate that word.
Right? So then the area has to be, I don't know, 1/2 of 30. So we're looking like 15 kerplunkerbunkles. I'll say units squared. All right, good. So that's easy enough, fair enough, we found that. Okay, so I want to actually show you something that's kind of interesting. Could you guys, let's give these vertices of these triangles, let's give them some names, like A, B, and C. What is that vertex A? What's the coordinate for vertex A? Or if I was on the unit circle, what would it be?
0, 0.
It'd be 0, 0. Very good. I agree with you. It'd be 0, 0. How about B? What would that coordinate be?
6, 0.
That'd be 6, 0 as well. What about coordinate C?
5, 0, 5.
What? Try again.
2, 5.
2, 5 sounds a lot better. There we go. Over 2 up 5. That sounds a whole lot better. 0, 5. No, that's definitely not on that. Okay. So, check this out, everybody. So, I have these coordinates. I have 0, 0. I have 6, 0. And I have 2, 5. Okay? Look what I'm doing here. I'm going to make a matrix. But since I have 3 coordinates in a triangle, right, 3 vertices of that triangle, I need, there has to be another column here to make a square matrix. So I'm going to actually make a column of 1s. Because I want 100% of the area of that triangle, so I'm saying a column of 1s. So what I did was, notice that I took each of the points here. Okay, this is point A, 0, 0. This is point B, this is 6, 0. And this is point C, 2, 5. And then I put it into a matrix, but to make the matrix square, I need a column of 1s on the end of that matrix. Watch what happens. Pretty interesting stuff. So, ladies and gentlemen, let's find the determinant of matrix A. Do you think it's going to be 15? So let's call this matrix A. So therefore, the determinant of matrix A. Hey, which row or column should we expand? We should expand row 1, right? So it's going to be 0 times, who cares? Well, it should be minus, right? Minus 0 times, who cares? Plus 1 times what? What's the leftover part? Let's see here.
6, 0, 5.
So I'm going to have 6 times 5? 30, right? Yeah, 30, right? So I'm getting 30 here. So the determinant of matrix A is 30. How do these numbers compare to each other? It's exactly half, right? Oh, look, a half, right? So if we take 1/2, the determinant of matrix A, we actually get the area of the triangle with that same coordinate. How crazy is that? So in general then, the rule is if you're given 3 points, say point number 1 is coordinate x1, y1. Point number 2 is x2, y2. And point number 3 is x3, y3. Then the area of the triangle with these coordinates is equal to plus or minus half the determinant of this matrix. The matrix with those coordinates in it, x1, y1, and a column of 1s on the end, x2, y2, 1, x3, y3, and 1. Why do you suppose there's a plus or a minus in the front there?
Positive, right? So
Yeah, because the determinant can either be a positive number or a negative number. So you use the sign to represent area to make it positive, right? Because there's always Area is always positive for us. Okay, Amy, give me any coordinate in that coordinate plane that you can see that we can actually put a dot at. Give me one. 3, 2. 1, 2, 3, 2. Okay, I like that one. Nelson, give me another one. 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. And then I'll give you one. I'll go over here. I'll go 1, 2, 3, 4, 5, 6, 7, 8. 8, -3. There we go. I'll give you this one here. Okay. There we go. That's a little bit more interesting. Okay. So the area would still be 1/2 base times height, but it's not necessarily easy to figure out the base or easy to figure out the height without using distance formula and midpoint formula and all that kind of stuff, right? So we're going to try and figure out the area of this triangle here given the coordinates in the coordinate plane. So we should write those coordinates down. What is this coordinate up here? We said it was 1, 2, 3, 4, 5, 3. Is that right?
Yeah.
Okay, what was this one over here? 3, 2. I like that. And what was this one down here? 1, 2, 3, 4. 8, -3. Awesome. Very good. Okay. Before we begin, though, it's always fun to guess. So let's see here. This square right here is definitely accounted for. So that's 1. That's 2. So what do you think the area of this triangle is? If that's 2 full squares right there, what do you think it is?
6.
If you had to guess. So we have guesses here.
5.5.
I have 5.5. What else do I have? I had 6. That's a reasonable guess, right? Based on what we've drawn in, square units. Okay, fair enough. So let's go ahead and plug in what we know. We have these coordinates. We have 5, 3. Remember, we had that column of 1s. I have 3, 2, column of 1s. 8, -3, column of 1s. Now, we need to find the determinant of this. So let's call this matrix A. Let's find the determinant of matrix A. So you guys want to use your calculators for this one?
Yeah.
Since there's not really a nice way of expanding this one. Okay, let's go ahead and plug it in. So over here, right, we've entered this matrix, 5, 3, 1, 3, 2, 1, 8, -3, 1 into our calculator. And we want the determinant of that matrix. So we're going to go math, get the determinant, matrix 1. And I'm getting 15, right? I'm getting 15 here. So the determinant of this is 15. So therefore the area is equal to half of 15. What's half of 15, you guys? 7.5. Were we close on our guesses? And we guessed 6. Is that pretty darn close?
No, it's not good enough.
You don't think that was good enough?
No.
Okay. All right, ladies and gentlemen, we're going to take a look at Cramers' rule now. Okay? Cramers' rule is another way to use determinants, and this application is for solving systems of linear equations. So right now we have 4x minus 2y is 10, and 3x minus 5y is 11. All right? Fair enough. This is a system of linear equations. We could use elimination. We could use substitution. We could even solve by graphing. Right? I'm going to show you how to use Cramers' rule, which involves determinants, to solve this system of linear equations. Remember, the answer should be what, you guys? The answer should be one number, two numbers, a point. What should the answer be for this?
2 numbers.
Well,
Determinant or
if it has one solution, it should be what?
what number?
There should be a coordinate point, an x and a y, right? What if it had no solutions? Then what?
No solution.
What if it had infinite many solutions? What would it look like?
It would be all real to.
Okay, let me ask you a better question. What would the graph look like if this had no solutions?
They would be parallel.
Parallel lines, very good. What would the graph look like if it had infinite many
The
solutions?
same line.
They'd be the same line. What would the graph look like if it had only one solution?
Crossing one.
There'd be an intersection point. So it's going to be one of those, okay? We're going to use Cramers' rule to learn how to do it. Here's the first step to Cramers' rule. And this works for solving systems of linear equations. And they could be, we could have 2, we could have 3, 4. It works all the way up the line. So here's the deal. We're going to put the coefficient matrix 4, -2, 3, and -5. I'm going to put that right over here on the right-hand side. The coefficient matrix is just the matrix with the coefficients in there. That makes total sense. So what we're going to do then is we're going to find the determinant of, I'm going to call this matrix A. So the determinant of matrix A is going to be, let's see here, 4 times negative 5 is negative 20. Minus a negative 6. So what do we get for that? Nope. I'm getting negative 14 out of this one.
Wait. Oh, yeah.
Yeah. Okay. So because, yeah, so the determinant of A is going to be that. Good. Now, remember, I want to solve for X and I want to solve for Y. These are the two things that I want to solve for, X and Y. Well, here's what I'm going to do. If you break this down into sort of like, consider this is your X column, this is your Y column, this is your answer column. If I want to solve for X, I'm going to pick up my answer column and I'm going to replace it over the X column to have this. 10, 11, and then leave the Y column the same. Negative 2 and a negative 5. So you see what I did? I replaced the answer column over here with the X column to get a new 2 by 2. You guys all okay with that part? Hello?
Yeah.
Do you see what I did? Okay, good. Great. Then, what is then the determinant for, I'll call this matrix X? The determinant for matrix X would have to be, let's see here, 10 times negative 5. What would that be? Negative 50. And then 11 times the negative 2.
It would be 33 total.
So the determinant for X would be what?
Oh, wait,
Negative 28. Negative 28. Good.
Wait a second, wait.
Yet. So we figured out the determinant for what I call the X matrix. So the determinant of the X matrix gave us a negative 28. So therefore, if you take the determinant for the X part, which was negative 28, divided by the coefficient of a negative 14, you get the solution solved for X. X equals 2.
What?
Yes, exactly. What? How is that even possible?
Dude, where'd you get the 14?
Okay, where did I get the 14 from? That's from up here. Okay. Okay. So that's that one. Determinants to do that. You guys catch all that? So they cross at 2, negative 1. Okay, so in your groups right now, take about the next 10 minutes, use Cramers' rule to solve this system of linear equations. So what's your first step going to be? The coefficient matrix, which would be what? Negative 1. 2, 0, 1. And then finally, 3, negative 4, and 4. That's your first step. Good. Okay, ladies and gentlemen, we got to move ourselves along a little bit. Most of you are on the right track, and some of you even finished and have the right problem. The determinant for matrix A, my coefficient matrix, you should have gotten an answer of 10. Then you need to find 3 things. You got to find X, you got to find Y, and you got to find Z. So to find each of those, you create, you replace the column that you're looking for with the answer column. So as an example, the X matrix should have been this: 1, 2, negative 3, 0, 0, 1, 2, negative 4, and 4. And then the determinant of this matrix ended up being a value of 8. Therefore, X has a value of 8 divided by 10, or 4/5. You do something similar for Y and Z. Your Y matrix should have been this. Should have been negative 1. No, sorry, that's not right.
Yeah.
Is that right?
Yeah,
Oh, yeah, that was right. Negative 1, 1, negative 3. 2, 0, 1. And then 3, 2, and 4. And you should have found out that the determinant for your Y should have been a value of negative 15.
Yeah.
Therefore, Y would be negative 15 divided by 10, or a value of negative 3/2. Doing something similar for Z, you should get negative 8/5. Okay, ladies and gentlemen, this is a cryptogram. This is a series of digits that's been encrypted by a code. And the encryption code is in that 2 by 2 matrix. So this matrix here, this 2 by 2 matrix, was a matrix that was used to create this cryptogram right here. And our job is to decode this cryptogram. And we're going to do it by using matrices and inverse matrices. Okay? So here's what we have to understand first. First, if this cryptogram was created using a 2x2, then I need to align my cryptogram into columns of 2s. So what I mean by that is I need to rearrange my cryptogram into columns, into 2 columns. So I'd have this. I'd have 143, 82, 66, 36, 88, 51, 59, 34, 68, 37, 112, and 63. So what is the order of that matrix that we have there? What order would that be? How many rows and columns would that be? Rows would be, this would be 1, 2, 3, 4, 5. This would be 6 by 2. Awesome, a 6 by 2. Awesome, okay, so now I need to undo the cryptogram, right? And the way that we undo the cryptogram is we multiply by the inverse of the key that was given to us. So the key that was given to us was 2, 1, 5, 3. So we need to figure out A inverse. So what would A inverse be? Well, let's see here. A inverse would be 2 times 3 is 6. 6 minus 5 is 1. So it would be 1 times switching the A and the D, and then switching the sign for the B and the C part. So it would be what?
3, -5.
It would be 3, -1, -5, and then 2. So it'd be 1 times that, so A inverse gives us this. So this is a 2 by 2. You guys agree with that? Okay. So can I multiply A inverse times my 6 by 2? Can I do that?
No.
No, I can't. But can I multiply my 6 by 2 by A inverse?
Yeah.
Yes, I sure can. So if I multiply this by my A inverse, 3, -1, -5, and 2, this is a 2 by 2. Is that correct? I'm allowed to multiply these because the insides match. What will that result be?
A 6 by 2.
The result will be another 6 by 2, but the 6 by 2 will be decoded. Okay, so right now this is what I'd like you to do. I'd like you to decode that 6 by 2 and place it here. So somebody already has. So what'd you guys get when you multiplied the encrypted matrix by the inverse of the key that was given? What did you come up with?
19, 21.
Whoa. Okay. 19, yep.
20,
21,
18,
18,
6,
6,
9,
9,
14,
14,
7,
7,
9,
9,
19,
19,
6,
6,
21,
21,
14.
14. Okay, great. Now, these numbers, notice none of them are negative, right? Well, that's good. And they're all between 0 and 26. How many letters of the alphabet are there?
26.
26, right? Okay, now look at that code. What is the 19th letter?
S.
S. How about the 21st? U. How about 18? R. 6. F. 9. I. N. G. I. S. F. U. Whoa. Surfing is fun. So,
Put it all up.
check it out.
No, I just-
That message right there, that message was brought to you by this cryptogram right there.